All right, let's try and finish off this chapter. And it is page 97. We've talked about prosthetic components. You've got the concept of the external hex where a chunk of implant is sticking up above, and that means that attaching abutment, or the transmucosal and attaching abutment, has to attach to the implant above bone level. It's fine. It means that all the junk is sticking out, and that means you can quickly change the angles of the abutment if you want. And you can attach it to bars, you can attach it to those little nipply things, which will have the housing that go over and clip on top. You do those situations when you have more interocclusal space, and you tend to have more interocclusal space when you're completely edentulous, because you've just had a lot more bone loss. If you've just lost one tooth, you tend to have more bone because the dentoalveolar process is higher on either side. So it tends to be for overdentures and complex cases, and it said in your notes that if it's a multiple bridge, well, multiple bridge means you've lost a lot of teeth, so you've lost more bone. Okay. And so that's the advantage of the external hex. The internal hex, of course, means that all the stuff goes within the implant. And that means you can have a very neat part of the transmucosal and abutment coming out. It can be thinner, it can be a lower profile, and it won't be so broad such that you have to have the metal shining through on the gum area when you're doing a premaxillary case. Otherwise, the gums look dark because the metal shines through underneath. That's quite a commonplace. And the other major advantage of the internal hex is that when you have the internal hex that goes the implant, have the internal hex that goes into the implant, the hex is, my knuckle is the hex, this is the hex, the internal hex receptor, female component. It attaches to the hexagon all the way around here, but beyond my knuckles are my fingers, which forms a funnel, and that funnel is like a wedge. So when the hex engages into the implant, and it can be in one of 6 positions, so you can choose the angle of the head over the top of the implant, which of course is useful. And then you get the screw that drives down into it, and it screws it in, and it wedges a funnel portion that's extended onto the hex engagement. It just causes this funnel part to move down, down, down. That funnel part is the Morse taper, and it literally causes the wedge. I showed you yesterday when I put stack another cup over here, and if I stack a cup here and I jam it down, I can't pull it apart because it's been wedged. And if I wedge it to a certain amount, i.e. with a screw, then I will get the Morse taper. And so that's good and well. We also talked about, and so the platform of the implant determines whether it's an external hex, an internal hex, or an internal hex and wedge, or internal hex with Morse taper. And that screw is very important, and the wedge is very important, because without the wedge, the Morse taper, it means that all of the load, all of the lateral load in the implant, all it means that if I've attached the implant onto if I've attached an abutment onto here, and I put the screw in there, it rattles about in here because the hex part only goes down about 2 millimeters or so. And so the screw part there is what takes a lot of the strain. Yes, the hex part takes some strain, but the screw part, there's still a lot of strain onto the screw part. And so if we are able to do the Morse taper as well as the internal hex, then that Morse taper distributes more of the load to more of the implant, creating a wedge and creates a more intimate contact. So in other words, if I grab your hand like this, that's one thing. But if I grab your hand like this and you grab my hand like that, that's what I always just show you as kids, then that's like more of a Morse taper, because there's much more intimate contact. And even if I let go, you can't let go. Or if I let go, or if I'm holding on, you let go, I'm still holding you. Whereas if I'm holding you like this, it just is one little part, and then it can break. And so the screw, and so that's actually quite a good analogy to understand Morse taper, is the intimacy of the contact and the greater surface area, and thus the greater load distribution transmitted from the abutment into the implant. I know that must make sense to you by now. So the type of the connection, that's called the platform. You've understood Morse taper, internal, external hex. And so now, okay, so the implant is placed. This is the top of the implant. This is an internal hex implant. It's in bone. It's right up to here. Actually, this is quite good because it can sometimes have a polished collar here that just pokes above the bone. So this becomes part of the transmucosal component. And then you put the abutment on top, which also has a bit of a transmucosal component. And so it's okay because what that does is that connection now, wherever you attach the implant, whether it's here or whether it's here, that connection now creates what's called a microgap. And that microgap becomes problematic because if you get crap and bacteria going in there, however good you think your connection is, it's like a wide open space in the wall for bacteria to jump in there. I mean, they can build cities and colonies even with a micro gap, a micrometer gap. And so if that connection is deemed to be a little bit further up above the bone, then it's further away from the area that it's going to damage, because it's sort of accepted that a microgap is inevitable, in spite of the fact that our machining today is much better than it was 20 years ago. We used to have big problems with broken screws, microgaps, screw loosening, this gets open, crap gets in there, you create this hydraulic pump, this micro movements going on, and it just kind of squeezes in, pumps in and out the bacteria shit, which then goes around the implant and then causes bone loss, which is the exact same, and bone loss around the implant is called periimplantitis, exactly like you call periodontitis around a tooth. And gingivitis around a tooth is called implant mucositis. So it's the exact same thing, same process, except that junction around the implant is much weaker because you've got no horizontal fibers inserting into cementum. Yes, you've got attachment at the bone level, but I'm talking about above bone level, the soft tissue cuff. The soft tissue cuff around the tooth is more protected than that of an implant. So people think, oh, implants, no problem. No, the problems are the same. And sometimes it can be more rapid because there's zero pain ever. You don't get sensitivity from root exposures, nothing, right? So implants are great, but they have their problems. And so then what I showed you yesterday, we talked about, okay, so the implant is placed. I can just put the coffee lid on it. This here is a cover screw. And so this is my cover screw in place. And then I can close the flap over. All good and well. If it was a tricky implant, if the bone was soft, the implant, and I want to ensure the implant doesn't get loose, I don't want any loading of any kind on this, I'll put the cover screw on. If I'm more confident with the implant, then what I will do is I'll put a healing head on. This healing head up to my wrist will then go through the transmucosal component, and it will shape the mucosa like this pretty little tunnel with the implant at the bottom. It will shape the mucosa all the way through, such that when you put the abutment over the top of it, you don't need to cut things open. It's already connected to the implant, and you're good. And so it saves a surgery. So the question becomes, well, why would you ever use a cover screw? Why don't you make everything transmucosal? Well, if you're not comfortable about it being a really solid implant and you want to leave it alone and you want to give it some time, or if you put some graft around the implant, you want to just close it and get primary closure over the top. Because remember, if you have the healing abutment, it's not primary closure, it's actually going to be secondary intention closure, and crap can get in there. And so if it's a delicate situation underneath, you won't do it. In addition to that, if you have a disc that protrudes through the gum, even if it's just a millimeter, it's still a little bit loaded, because food bolus will get it. It'll just be slapped around a bit. It's not going to be forced on and used like a tooth, but it can get slapped around a bit. So it's a question of your gut feeling and how you feel about how delicate the problem of the procedure was. And of course, the implant, when it's inserted, you have a carrier. Everything that touches the implant is going to be hex engaged. So you have a carrier that goes, a carrier that takes the implant to the site. It's in a finger driver. It's a plastic finger driver, and then you turn it in. You start it, throw the carrier away. Then you get an implant driver, a metallic component that drives the implant home, and that drives it all the way down. Then we talked about cover screw. Yes, we talked about so the healing button. Okay, so we've covered that. Now the question is, how are we going to take the impression? Well, if we go ahead and we put the abutment and we just attach it in the mouth onto it, and if we've got the transmucosal part of it, we've chosen it well, so that means the transmucosal part then creates a margin, because where the transmucosal part becomes the abutment part that's in the mouth, that junction, of course, is the margin of the crown. So if you've chosen an abutment and you have, all systems have multiple 1 millimeter, 2 millimeter, 3 millimeter, 4 millimeter transmucosal parts attached to the abutments, which imply to us that how thick the mucosa is. For example, in the posterior mandible, the gum can only be sometimes 1.5 to 2 millimeters thick. In the premaxilla, sometimes it can be 4 or 5 millimeters thick. So that you need to vary the transmucosal height for the abutments that you choose. So that means if you've taken the margin up there, well, fine. So you've got this margin sticking up like this. So go ahead and take an impression like you would for a regular crown or a bridge or an inlay, and then just make a crown and stick it on, and you're done. But but there's another way of doing it, and in more complex cases, is that you will attach, like you see in the bottom of page 97, you will attach one of those posts, and it will, with an internal hex, and it will engage. Not Morse tape are needed here, because we're just taking an impression. We're not trying to load it. So what you're seeing on the bottom of page 97 is an impression post, and that impression post then is attached to the teeth, and it's just poking up like this. We then have a special tray made that fits over the top. So the impression, so the post is like that, and as it pokes out, we then, so my arm now is the tray, and within my arm I've got a big load of impression material. And so we swathe this big post that protrudes through, and I encompass that into the impression and the impression tray, and it pokes through the top of the tray into the patient's mouth. We allow it to set. Now if I try to pull this out, well, I can't pull it out because I've screwed it in, haven't I? I've screwed it into the implant. But now, in spite of the fact that the impression tray, as you can see in bottom 97, is over the implant, the little screw that protrudes through the tray, I can either unscrew it with my hand, or I can take the driver and I can unscrew it, and that will disengage the implant. Because the implant is now engaged with the impression post, and the impression post is engaged with the impression material within the tray. And now, if it wasn't for the impression post, you could just pull it off like an impression for anything else. But now you have to undo the impression post. And when you undo the impression post, you will disengage, and then you can separate. And so now, you take this out, and you've got the impression post here. Well, then all you do is you get an analog implant, pretend an identical size and shape implant, but a cheap one, because the implants cost about 200 or 300 euros, but the cheap ones, the analog that you're going to use for the lab, is the exact same dimensions to give you the information, but you attach it to the impression post, and they cost like 10 bucks. And then you attach it there, and then you pour this up. Then you turn it back upside down, unscrew it again, and you leave the precise appearance of the metallic analog inside the model, and you've got all your soft tissue information, and then you can choose your abutment from the lab, or you can make a custom abutment, but you're not talking about that here, so we can talk about that another time. So that's that part covered. And so now onto page 98 then. Here we've got torque and preload. You know that torque, when you have torque, well, torque and preload is kind of similar because torque is tightening. So torque is how much effort I'm going to put into tightening something. So if you have a screw, and I'm going to put a cover screw on here, and I just tighten it, and it just goes down. Well, it's all the way home, that's fine. But let me say I do that with an abutment, and I tighten it, and it's home. This part is contacting, so the two edges, they meet, and the screw is home. It doesn't mean that the screw is tight. All that preload means is a fancy way of saying how tight. So yes, this is closed, as I could put the bolts on, and I've done it finger tight, on the wheels for your car, but that doesn't mean I've put any effort into it. If I put more effort into it, it doesn't mean that the bolt goes into the wheel, okay? Because the bolt is all the way done. There's 10 threads, and I've put 10 screw threads in, and it's home. But the preload is how much I tighten it. Why is that significant? Because the preload will determine a certain amount of tension and will ensure that you've achieved the machine precision intimacy between the components that you're using. So all that preload means is how tight. And we basically tighten things by 20 Newton centimeters. So we have a torque wrench, and we know that when we use it, we set it to 20, and it breaks at 20. Breaks means like a bendy arm. It breaks at 20, or we have a spring lever, and we see that it goes up to 20, and then we've gotten it. As it happens, any given wrench, finger wrench, with these two fingers, if we tighten it, no matter how strong you think you are, you can't do more than 20 to 25 with your fingers anyway. So most experienced practitioners, like myself, don't use torque wrenches because we know we're getting 25 when we tighten it with our fingers. We're not actually capable of tightening it more than 25 with our fingers, and that's got nothing to do with how strong I am. All the musculature is in your fingers. And for me to say I've got stronger fingers than you, why? Because I've got big bulging muscles on my fingers? No. That's not how it works. So it tends to be finger tightening, is 20 to 25. And of course, when you put that proper preload and you put that proper tightening of 20-25, which is called preload, then you've got the appropriate wedge effect for your internal, for your Morse taper. So let's talk about the types of implant prosthesis. Now you can create implant prosthesis where I described, you screw the abutment into place, you've got your preload, you've got your torque, and you've got your internal wedging effect with the Morse taper, and then you build your crown over the top. But if you build the crown over the top, you're also covering up the cover screw. And so if for some reason, I don't know, you didn't tighten it enough, or years later there's a problem, and you want to take the crown off, you can't take the crown off because you've cemented it on. So you have to cut the crown off and then unscrew the abutment. Okay? And so you can have two faults. So that means, and that can be a real problem if you've got, say, I don't know, 8, 9, 10 implants on a jaw, and you've put a hole and you've cemented a whole bridge. I may have to tap the bridge off, but it could cause damage. It could break the porcelain. If you have a problem with one implant, I don't know, a piece of chicken bone got stuck in one implant, it caused its failure. You want to take everything off. You want to remove that implant, maybe modify the bridge and then cement it back on again because it will still work with 9 implants. The point is it's much easier to do if you have a screw retained. And if you look at the screw retained crown bridge, you will see most of the way down 98. One is a cemented crown and the other one is a screw retained crown. Now the other thing with a cemented crown is that you don't have an excess of cement that gets squeezed around in the gum line that can cause a problem. Whereas with a screw retained, there is no cement. You're just undoing it. So technically a screw retained crown is better, it's safer, it's more versatile, but there's a catch. If you have a screw retained crown, it means the top of your crown has a hole for your screw head, and you have to fill it up with composite. A lot of my patients get pissed off and saying, wait, I've just spent how many thousands for this, and I've got this bloody great filling in my $5,000 crown? You got to be kidding me, right? And so having it screw retained is not pretty. It's the only way of doing things. If you're doing a bar, you screw the bar down. You don't cement the bar. Well, they did in the teeth, as you pointed out to me. But generally speaking, you screw down the bar. So screw retained is important, but the disadvantage is that you have a hole right in the middle of the fossa of the tooth. It's ugly, and the porcelain can sometimes fracture, and so that's basically an issue as it's indicated on the graphs there. Now, Misch's classification, these classifications, remember we had density 1, 2, 3, and 4. Density 4 is super soft. Density 3 is okay. Density 2 is okay. Density 1 is super hard. And we've discussed it with cortical versus cancellous bone. It's a Malteser. That's the best way of doing it. I usually hand out packets of Maltesers around to everybody. Yes, I do share sometimes, even Maltesers, during my lectures when I want people to understand bone density. And the thicker the chocolate, the closer you are to D1. And D1 is not good because you don't have much blood supply in that bone. It's too tight, you burn the burrs, you tighten things up, you squeeze the osteocytes, you kill them, you have problems. On a D4, well, you don't have enough bone to work with, and the whole thing is too weak. And so D2 and D3 is usually a whole lot better. But now here, the same Misch had a different classification, so that was bone, and then you had the Zard classification for how much alveolus was gone. And you had classification 1, again, I think it was 1 down to 4, as to how bone was being resorbing. And the maxilla resorbed from the outside in, the mandible resorbed from the inside out. Okay, so if you have got, so this Misch's classification here pertains more to when you've got more bone loss. So if I just had my tooth knocked clean out with an elbow playing basketball or something, then I put an implant back in, and I build a tooth, all I have to do is replace the tooth. But if I had my teeth knocked out and the bone was allowed to resorb, and I couldn't afford an implant now, and I had to come back in a couple of years, the bone would have resorbed a little bit. And so when I replace the two teeth, now the 2 teeth have still got to be in alignment with the rest of my teeth, right? But it's resorbed, but it's lost bone. So everything above the bone level, so in other words, what happens is the transmucosal portion gets bigger and bigger because your occlusal plane is here. The occlusal plane doesn't care how much bone you've lost as a result of gum disease for losing the tooth, or from trauma, or from resorption. It doesn't care. You're still going to have to build the tooth to here. Just because I've lost a lot of bone going up there, it doesn't mean my teeth can be shorter. Okay? And so what you're effectively doing then is that you're losing bone, and so when you put a tooth in where you've lost more bone, everything above the implant is slightly taller than it used to be. Okay? And so we categorize how tall. Well, if it's perfect, then we have an FP1, fixed prosthesis, 1. If it's less than perfect, if I've lost my tooth and a bit of the buccal plate was gone and we didn't graft it, and so we're replacing the tooth, but the tooth has got to be a little bit elongated. Well, that's an FP2, because we're pretending that the tooth we're replacing, well, it's just a bit of a taller tooth. So that means part of that tooth length that you've had to make it taller, is because you lost some gum and bone. Okay? Well, you've lost a little bit of gum, and so one tooth is a bit taller. Okay? And so, and sometimes you may have to do you may end up with a longer looking tooth because you lost a little bit of the gingiva. Now, an FP3 is, so it looks like it's a receded gum around the tooth. But an FP3 is if you've lost gum and bone, and so therefore therefore the tooth gets longer and longer. So all of this, as you know, means that your crown-root ratio goes from FP1 ideal, FP2 crown is getting a bit taller, FP3 it's getting much more. All that means between FP1, FP2, FP3 is crown-root ratio increases. Okay? And typically in an FP3, they put pink porcelain and they actually make a part of the crown look like gum tissue, solid glass gum tissue, but it's gum tissue. Why? Because bone and gingiva is missing in an FP3. In an FP2, it's just gingiva that's missing and your tooth is a little bit taller. And FP1 is everything's perfect. In fact, even if you look closely, sometimes you can hardly tell if the work's done really well. And then you have a situation where you've got an RP4. An RP means removable prosthesis. So an RP4 is implant supported or implant retained. You know what that means. Removable prosthesis. So your implant supported over denture. So in other words, if it's going to be removable, an RP4 is that it's going to be removable. You've got the stability, the retention, and the support is by the implants. And if you have RP4 is if it's effectively everything is supported by implants. All forces go on implants. So the smaller the number, like an RP4 versus an RP5, the smaller the number, the better it is. Like an FP1 is better than an FP2 is better than an FP3. Well, an RP4 is better than an RP5. An RP4 is more like natural teeth. So I either have a denture or I have a bridge that I put into place on 5 or 6 implants in the upper, and all my biting forces goes all the way down into the down into the implants and provides me complete support. The RP5 means I need to have some soft tissue. I've only got 2 or 3 implants in place, and so I'm tissue supported as well. Okay, so you go from FP1 all the way down to RP5, and the difference between the RPs and the FPs is that RPs are removable, and in spite of the fact that you've got an implant supported and an implant retained, the denture is still removable. It's still the same force as a bridge. Okay, but you see, if you had, I don't want you to get confused here, because you can say, well, you can just put a regular fixed bridge. Well, if it's a regular fixed bridge and it's non-removable, then you would categorize it according to FP1, FP2, FP3. You see, it's not just for individual crowns. It can be for big bridges. You can have an FP1 multi-tooth bridge, which has no gum and bone loss. So that's an FP1 bridge. If you've got a bit of bone loss or gum loss, then it's an FP2, and it's a bridge all the way around the mouth that's fixed, a bridge the way I understand it. The RP4 and the RP5 is specifically for removable stuff. Okay? And so that brings it to the end of that chapter, so let me stop this video so it's not too big to send to you.